Coming back with number 5, we do have a equation modeling the speed of a Corvette after time t in seconds, where the speed is listed in X miles per hour. So I have written that on my paper and things. I'm not going to write it repeatedly because this equation is nasty and what a waste of my life. What I will recommend that you do to get this into Wolfram is just copy it right out of my presentation and paste it into Wolfram. That will save you some headache. And our first question A is going to be, how fast is the Corvette going after 8.99 seconds? And so typically the 8.99 seconds would go in here for X, but in this case, X is representing miles per hour. So we do need to put that 8.99 in for T there on the left side. Again, I normally write all my work out, but I'm not going to this time because I don't want to rewrite this silly thing multiple times. So in Wolfram, we do have two solutions that come up. One of them is negative and one of them is positive. Now, this is a Corvette, not a DeLorean. It is not possible for this car to travel backwards in time, so this solution is not valid. It means it doesn't exist, so we're going to ignore that one. And we're going to look at this one right here. We are going to see that X, when T is 8.99, X is equal to 96.9963. And we were asked to round our answer to the nearest mile per hour. So that is about 97 miles per hour. So after 8.99 seconds, the Corvette will be going 97 miles per hour. That's pretty awesome. Moving on to our next question, we are asked two questions. How long will it take for the Corvette to reach a speed of 150? And how long will it take for the Corvette to reach a speed of 250? So for part B, let's go ahead and go back. And instead of 8.99 here, we're going to put our variable back in there. And we are looking for when is the Corvette going to reach a speed of 150 miles per hour? So we do need to put that in for X in both spots in our equation and see what Wolfram has got for us. So interestingly enough, we only get one result this time, not two. That's 19.39. That rounds down to 19. So it will take about 19 seconds for the Camaro Corvette to reach a speed of 150 miles per hour. That one is possible. I'm not sure if a Corvette actually has the potential of reaching 150 miles per hour. I'm almost positive that a Corvette is not capable of going 250 miles per hour, but let's put 250 in and just see what comes up. This is going to be an example of how it's important for us to pay attention to how realistic these models that we are using are, because this is predicting that after 50 seconds, so I'm going to say the model predicts that the Corvette will be going 250 miles per hour. Don't know why my iPad just disappeared. I'll fix that. So the model does predict that the Corvette will be going 250 miles per hour after 50 seconds. Again, I don't think it's possible for particularly a stock Corvette to go that speed. Let's test the model and see what it says if we want this Corvette to go 1,000 miles per hour, which we all know is impossible. It says that it would take about 748 seconds for it to do that, which is about 12 minutes. That's awesome. That's impossible. So this model is broken after a certain point. It is your responsibility as the person who's using these models to think about the reasonableness of the result. Like in this case, there is no way that a Corvette is going to be going 1,000 miles per hour in 12 minutes, or no matter how long you give it to accomplish that period. So again, very important that we are being realistic about our predictions using these models.